Welcome to Leetcode number 217, contains duplicate. So this question is actually pretty popular at companies like Microsoft, Google, Amazon, PayPal, and so on. And it's part of the blind 75, so it is one of the 75 problems you should be studying to ace your technical interviews. So for this problem, they're not going to ask you this problem because of its technical complexity. They're going to ask you it because they want to force you to find other solutions. So you're going to code up a solution, and then they'll say, okay, but now do it using this, and so on, or do this in a faster time complexity, better memory complexity, and so on. So I'll be explaining 3 solutions in this video. They will become more and more efficient as the video goes on. So basically what we're doing in this problem is we have an array or a list of numbers, and we want to see if there's any duplicate. So let's check each number in this first test case, 1, 2, 3, 1. We check 1, okay, cool. We check 2, no duplicates so far. We check 3, no duplicates. But then we check 1, and we can see that obviously 1 is repeated. So now we have a duplicate, and we return true. We do have a duplicate. So now if we go into example 2, we iterate through the array again, 1, 2, 3, 4. None of these numbers are repeated in the array. Awesome, so let's code our first solution. So imagine we have an array like so, 1, 2, 3, 1. If we sort the array, you'll notice something happens. If we sort the array from least to greatest, we now have an array that looks like this, 1, 1, 2, 3. Now you'll notice it's very easy to find duplicates now that it's sorted. So we can use this in our algorithm to help us find the solution if we sort the array first. Every number that has the same value as a number next to it will be a duplicate. So therefore we can return true if we sort the array and then we find that the number next to another number has the same value. So that's going to be our basic solution. That's all it is. And let's code up a base case for this really fast. So let's say that we have nothing inside our list. How can there be any duplicates? So we're going to return false. And what if we only have one number inside our list? Well, we're also going to have to return false, as a duplicate requires 2 numbers to be a duplicate. Okay, so let's code up this base case really quick before we get to our algorithm. So it's just going to be a simple if statement. So if the length of nums is 0, or if the length of nums is 1, what are we going to do? We're going to return false, as there cannot be a duplicate if there's not enough numbers to contain a duplicate. Now, if you'll remember our original algorithm, let me draw my array here. We're first going to sort this so it becomes 1, 1, 2, 3. And then from here, we're going to iterate over every number in this array and check for the next number. So you can see the steps here. First, we sort. We sort to get this array. And then we have a for loop to iterate over everything. So we know that we're going to have to sort everything first, so let's do Python's built-in sorting mechanism here, nums.sort. Now that we have everything sorted from least to greatest, we can use a simple for loop. So let's say for x in the range of the length of nums minus 1. What are we going to check? If, remember, if this index is equal to the next index, so if nums at index x is equal to nums at index x plus 1, what are we going to do? We're going to return true. Because if this index is equal to this index, then obviously we have a duplicate. And if this index is not equal to this index, then we don't have a duplicate, and so on. So if we go through every single number in our array and we find that nothing matches this criteria, then we know that we don't have any duplicates. So we can just do a return false down here. So that's our code. That's all it is. But now that we have our code, let's analyze the time and space complexity, because you'll also need to know this for technical interviews. So the things that affect our runtime will mostly be this nums.sort method, which does a sorting algorithm under the hood, and our for loop, which iterates through every single number in nums, essentially. So this for loop is time of O of n, as it iterates through n numbers, n being the size that we input. So, and then nums.sort, under the hood, it's an average of O log of n. So from these two, we take the largest number, or largest time complexity, And we can see that this algorithm is time complexity of O log of n. But now what about space complexity? So as you can see here, we don't create any hash maps or arrays or anything that contain a lot of size. We don't really create any big variables. So we can just assume that space complexity is just O of 1. But what if we wanted to find a faster solution, a solution that has a runtime of O of n, where we just iterate through every number once in the array, and we don't have to do any sorting? Well, there is actually a way to do that if you know a little bit about data structures. So there is this thing called a hash map, where essentially we can store key value pairs, so 1 to 0, 3 to 5, and so on. How this helps us is Python has a method where basically you can see if a key is inside this hash map. So what you'll notice here is if we have our array, let's say 1, 2, 3, 1, and we go to this number here. Well, let me delete this sample hash map first. So let's say we iterate through our list here. We see 1, and then is it inside the hash map? No. Okay, let's add it. We'll just add 0 as a placeholder, by the way. And then we go to 2. Is 2 inside this array? Hash map? No. So we add it. Let's go to 3. Is 3 inside this hash map? No. So we add it. Now we go to 1. Is 1 inside this hash map? Yes, we found it. So then we're going to return true. Right? So essentially we are going through every number, we're storing it in the hash map, and then if we find it again, then we know that we have a duplicate, right? So let's code up our solution. And remember, we have the same base case as before. So we're just going to write out our base case again. So if the length of nums is equal to 0, or the length of nums is equal to 1, we want to return false, as a duplicate requires 2 numbers to be a duplicate. Okay. So what we're going to do here is we're going to declare a hash map, or a dictionary. Python calls it dictionaries, but they're also hash maps too. And then remember, we're going to do our for loop to iterate through every single number. So let me draw the visual here again. So we have our 1, 2, 3, 1, and then we have our hash map like so. So we want to iterate through every number, and if it doesn't exist here, then we want to add it to this hash map with just a random number as the value. So key value. And we're going to iterate here to 2, add it if it doesn't exist, and so on. So obviously we're going to need a for loop to iterate through everything. So let's set up a for loop for x in nums. And then we're going to check, remember, if x is in our hash map, what can we do? We can return true. Because remember, once we saw that 1 was already inside our hash map, then we know that we have a duplicate, so we can return true. But what if we don't have that value already inside our hash map? Well, then we know that we need to add it. So we're going to say the hash map at index x is equal to 0. Now what if we go through our whole for loop and we haven't found any matches between the hash map and the array? Well, then we can just return false because we know that there are no duplicates inside the array. So now that we have our solution here, this is all the solution is. What is the runtime and the space complexity of the solution? So you'll notice here, the only things affecting our runtime are the for x in nums, which is essentially just a normal for loop. All standard for loops such as iterate over the same length as the input will always be O of n. And there's nothing else affecting our runtime massively, so that will be our runtime complexity. Now what about space complexity? Last solution, it was O of 1. We didn't create anything, but you'll notice here we create a hash map, and we're adding values to the hash map, and the hash map can be as big as the length of nums. So therefore, our space complexity will also be O of n, which is worse than the last solution, but the runtime is better. So you really pick and choose if you want better runtime or better space complexity between these two solutions. But there's also a third solution, which is a little bit nice if you know a little bit about data structures in Python. So let's say we have our list like so. We have our list 1, 2, 3, 1, for example. And there's a data structure in Python called a hash set. A hash set essentially is very similar to a list, except it doesn't contain any duplicates. So if we convert this list to a hash set, it will automatically remove all the duplicates. So our hash set will have the values 1, 2, 3 if we convert from list to hash set. Now you might be able to guess why this would be helpful in our solution. So essentially, if the length of our list is not the same as the length of our hash set, something had to be removed. And we can assume that a duplicate was removed. See how these ones were condensed into a single one, so therefore the lengths changed. So if these lengths are not equal, then we will return true, because there is a duplicate inside this. So let's go to the solution. First, we're going to have our base case the same as before. I'm going to say if length of nums is equal to 0, or the length of nums is equal to 1, what are we going to do? We're going to return false, as a list cannot contain a duplicate if there's not enough numbers for a duplicate. And now we're going to declare a hash set, and we can do so in Python like this. We can use the built-in set function to convert essentially our list nums to a set, a hash set. Now that we have our hash set, we can just return the boolean. So we're going to do a comparison here. So if the length of the hash set is equal to the length of nums. Made a bit of a typo here. Now remember, if this condition is false, then we want to return true. And if this condition is true, then we want to return false. So we're going to put a not beforehand to negate this. So it basically flips the answers. Because remember, if we had to remove something from this list to create the hash set, then that means that we have a duplicate, so the lengths are not equal, so it's true, right? So now, what is the time complexity and space complexity of the solution? As we can see here in our code, we don't really have anything to drastically increase our runtime except for this set function. This set function under the hood essentially runs through every number in the list in O of n time, so that is going to be our time complexity. And what about space complexity? So as you can see, we are declaring a hash set here, which has a list of numbers that can be up to equal the same size as the input nums list. So therefore, this will make our space complexity O of n space.